So yes, I am
Yeah.
excited. Just to be clear, I am not one of those AI alarmists that we hear a lot of in the media today, but it's not because I don't think there's nothing to worry about at all, right? I think AI is a singularly powerful technology that can be used for good or bad, and there are many things that can go wrong. And I am guardedly optimistic about the future based on our experience with technology today, which is like we humans, we make the good things happen and prevent the bad things from happening. So we got to have that conversation. The only thing the AI wants to do is maximize its objective function, which we determine. So the idea that a smart AI is necessarily a danger to us or out of control is actually is mistaken. So for example, consider, trying to cure cancer.
In the next couple of years, do you buckle up? Is it going to be pretty cool?
It is going to be pretty cool, I think. And I think we should buckle up. Again, how far and how fast this is going to go is very hard to predict.
Hello, everyone. Welcome to another episode of the Bounce Pod. So recent developments in AI, specifically the consumer-facing generative AIs like ChatGPT, Bard, DALL-E, Cohere, so on and so forth, is not only helping people create original content and art, but is also generating a lot of excitement and concern. And the big bucket of concern is about AI alignment. What are the possible unintended consequences to humans? The internet transformed our relationship to information, but over a period of years, in just a few years. But now AI is taking it to another level and doing it in real time. So I'm going to time stamp the date here, May 2023, because I don't know how this is going to age with the rate of change here. Okay, so AI anxiety is now a thing, and if you read the headlines these days, that is understandable. There is the proposition that fear of the unknown may possibly be the fundamental fear. Uncertainty is certainly a core element of anxiety, and one of the best ways, I think, to lessen anxiety is with understanding brought about by more knowledge. So this podcast is an effort to gain that knowledge from someone who knows these technologies intimately, and I just want to see if we need to worry, or maybe how to worry wisely about this. I'm not saying we shouldn't be concerned, but I want a reality check, and I want to chunk down the concerns to find out which are more probable than others, and also what's the risk-reward ratio here. So my guest brings a wealth of expertise in all things AI, machine learning, and large language models. Professor Pedro Domingos. Pedro is a leading AI researcher and the author of the worldwide bestseller, The Master Algorithm. He is a professor of computer science at the University of Washington in Seattle. He won the Special Interest Group on Knowledge Discovery and Data Mining Innovation Award and the International Joint Conference on AI John McCarthy Award, two of the highest honors in data science and AI. He helped start the fields of statistical relational AI, data stream mining, adversarial learning, machine learning for information integration, and the influence maximization in social networks. So on this episode, we run the gamut of the actual, conceptual, and speculative. We talk about where we are with generative AIs. Pedro kindly explains and demystifies large language models. We talk about progress and problems with generative AIs like ChatGPT and Google's Bard. Hallucination in AI and illusion in humans, the homunculus fallacy, risk, regulation. We talk about the S-curve in emerging technologies like AI, its possible impact on employment and the economy, artificial general intelligence or AGI. I ask him about goals and end games. Is AGI or human-level intelligence, is that the goal? And I ask if he thinks large language model AIs like chat are conscious in any respect. I think you'll find his answer very interesting. So no matter your technical level, I think you'll enjoy this discussion with Pedro. He is very passionate about the subject matter, which is no surprise. Much of what he's predicted has come to pass in the field. And if you feel a tinge of AI anxiety, consider this a bit of exposure therapy. Learn about it. Give it a listen and find out how these systems work and how they might impact your life. So here's Pedro. Pedro, welcome to the show. Thank you for coming on.
Thanks for having me.
Very excited to talk to you. And it's so timely, I can't even keep up. I'm not sure how you're doing.
Neither can I.
I'm not sure I've seen anything like this. How about you?
It's true. I mean, like I've been through several waves of technology, but I mean, I always thought that, and again, that's part of why I got into the field, that AI was bigger, and it is turning out to be bigger, at least in the amount of worry and excitement and that it inspires in people. I mean, in terms of actual impact, of course, AI is still, far from other things and far from where it's going to be. But in terms of just the level of public argument about it, it's really something. I'm an AI researcher. I got my PhD in machine learning back in 1997 when no one cared about that. And I claimed that one day it would take over the world. And I feel very vindicated now. I continue to do AI research. I've also written a book called The Master Algorithm, which is an introduction to machine learning for a broad audience, because I think at this point, everybody needs to have some understanding of the technology, both for their own uses and in terms of the public helping to make policy decisions and whatnot. I recently wrote a novel, another book, a
Really?
satire of the tech industry and its collision with politics, whose plot, I kid you not, is essentially that ChatGPT runs for president.
I love it.
And I wrote this before this whole thing exploded in the last few months. So there you go.
You've written it, or you're writing it, or it's out?
No, I have written it. My agent is looking at it right now. I'm going to still make revisions and whatnot. So it'll be probably months to a year before it comes out. But it's very timely, I think.
I would love to read that. But back to the point, I read your book back when it came out. When I was at Google, I think I read it. And another friend of mine, I said, "Hey, I'm talking to Pedro." He's like, "Oh yeah, I read the book. I need to reread it." And so I'm looking at it. And then you gave a talk, I want to say 2017, 2018 at Google. But anyway, you said this. Right. We're speaking of prescience here. You said at the moment, and I'm just a little snippet here. You said at the moment, in order to program a computer, you need to know how to code or be a computer scientist. In the near future, anyone will be able to program a computer without any knowledge of coding. You just need to explain in plain English what you want your computer to do. Well, here we are. And I remember when I was at Google and I'm in an engineering office and I'm talking high-end, engineers. And I said, guys, code is the first thing it's going to be, that's it. They laughed. And mainly because they're working on technical debt and spaghetti code, right? They're like trying to disentangle and they're like, there's just no way. So anyway, here we are. The first thought was, man, was he working on codecs at the time? I mean, you just kind of saw this natural progression.
So I was working on something related at the time, because one idea that I always had, and I had a student working on for a while, was, can't we start by doing machine learned debugging? Right? You have a corpus of programs and compiler results, so you can actually tell that someone fixed the bug somehow. Right? And there's large repositories of this right now. So our idea was you start with there, and then at some point, there's no distinction between very buggy code and pseudocode. And at some point, there's no distinction between pseudocode and natural language. So it's a very natural progression from like, you want to have a big goal, but you also want to start with something that's feasible. Pseudocode to natural language is a natural progression. But honestly, this was always on my mind since I was an undergraduate student, because clearly, if you look at the history of computers, in the beginning, people programmed by setting switches, and then came assembly code, and then came high-level languages, and then it stopped. There are more and more abstract languages, but they all have this very formalistic notion that you have to get everything right. Whereas, I always thought of this at times like, the spectrum of communication. There's what the computer knows, the silicon, and there's what humans speak. And our goal, should be, or I think is, to gradually progress from the language of the computer to the language of humans. But at some point, things kind of went off in the wrong direction.
Yeah.
So one of the things that always interested me in AI was precisely this notion of letting anyone program. Also because you see the need and the potential, right? Imagine all the good that can be done if people can just, write programs for themselves and for others and share them. It'll be progress on a different order.
So let's just jump right in. And you're the man to talk to about this, as to where we are today with AI and where you think we are. And then because of what's happening of late, let's start with the generative AI like ChatGPT. And large language models are now kind of mainstream. People hear that all the time. I'm not sure everybody understands what that is. Could you just summarize or simply explain what a large language model is as far as algorithms and deep learning as it relates to the consumer-facing AIs? This is your field of expertise here.
Sure. The first part of that is to understand what a language model is before we get to the large part. And the language model is actually a very old and actually quite simple idea. People have used language models for speech and translation since at least the 70s, and that's where it originated. And the simplest language models, which prior to the modern deep learning wave were still the basis of things like Google Translate and the speech recognition on Siri and Android and whatnot, is just the following. I want to predict what is the next word that you're going to say. And in traditional so-called n-gram models, a gram being a word and n being the number of words that you look at, I just predict your next word based on your previous word, the previous 2, 3, or 4. And the thing that is extraordinary about these models, I mean, it struck me when I first played with them, and I think it strikes anyone, is that as you condition, to use the jargon, on more words, so what is the next word given that I know the previous one, given that I know the previous 2? The dog chased right at that point, it's like, oh, cat, right? So as you condition on more words, it starts to get more articulate remarkably quickly. So I'll give you an example. My kid, when he was 13, wrote what he called the Markov bot, because this is based on something that Markov initially, the Russian mathematician initially invented. That was a 4-gram model, so conditioned on 4 words. Trained it on a bunch of journals. This was, something wrote in Peril fairly quickly. In Python fairly quickly. And then he gave me a paragraph to read and said, "What do you think?" I said, "Yeah, this is the standard journal affair." And then he revealed to me that this had been written by his Markov bot. So this is with no deep learning, no nothing. You can already do this well. Now, the problem with this is that as you condition on more words, the amount of data that you need to learn the model goes up exponentially. And the thing that made, things like Google Translate and Google Spell Check and whatnot very successful is that there was more data, and so you could build longer models. And in a way, with all the many different, very important pieces of technology that went into them, large language models are at heart just doing the same thing, except on a way larger scale. And people are surprised at how amazingly good the text it generates is. But really, if you extrapolate the curve from the n-gram models, fast forward to conditioning on much larger context and so on, it's really not surprising that this is what's happening. There's a really crucial thing here. I will single that one out, which is transformers and attention.
And that came from DeepMind, I think, in 2017. Wasn't that critical into chat being what it is, the transformers?
Absolutely. That's why I'm bringing it up. So there used to be what is called statistical machine attention, and transformers originated in machine translation. And there used to be what is called statistical machine translation, which is what I just described. And then Yoshua Bengio's group in Montreal, which actually doesn't get enough credit for this, they're the ones who invented attention. And then the guys at Google, right, who do get a lot of credit, they invented transformers. Transformers are just using a lot of attention stacked many layers deep for many. They wrote the famous paper called "Attention is All You Need," and their argument was like, well, once you have attention, you can do away with all of this other stuff. So what is attention, right? You see a lot of descriptions of LLMs and transformers that actually don't get to this, and this is really the crucial fact, is that attention is a way to not have to condition on all the previous words. You choose, attention is you're choosing which previous words you pay attention to when predicting the next one.
Is this context? Is this coming into understanding context?
Yeah, the context. But for example, your context is your entire previous text or your entire previous life, if you will. But that's too much information, right? Too much search, too much opportunity for noise and overfitting. And the attention idea is like, think, for example, of translating Spanish into English. It's not just a matter of translating word for word, which is what, n-grams can do very well. Sometimes word order changes. Right? The adjective comes before, after the noun and whatnot. So you need to know, when I'm generating the next word, what is the previous word that I'm translating? Is it just the previous word, or is it several, words ago, right? And now this turns out to be a mechanism that is incredibly general, very useful beyond just translation or even language, which is really at the heart of why suddenly large language models can do so many things so well, because really at heart, the machine learning mechanism there is really just a sequence prediction mechanism. And in fact, the guys who developed transformers, and I've talked to several of them, their goal was explicitly to come up with something like a universal model. So this idea of the master algorithm that is the title of my book is actually very much what they were aiming for, and we're clearly making progress towards it. So these are all predicting the next word. The way ChatGPT works. And again, it's very important to understand this before you get confused about how smart these machines are and how they're going to take over and whatnot. The only thing that it's doing is predicting the next word. Now, predicting the next word is actually an incredibly powerful thing to do. So when people say like, oh, well, it's just, filling in the blanks or autocomplete on steroids. Well, autocomplete on steroids is something very worth having. Now, the big difference that transformers made was that effectively through this mechanism of attention, they allow you to condition on much more than you conditioned before. So as you're trying to predict what the next word is, that prediction can actually be based on a lot more information, right? And then there's several other things that go into this, but that is really, I think, the key. But then the next thing that happened, again, kind of compressing things, was that OpenAI said, we're just going to scale this to the limits. I remember when a model with 1 million parameters was big, and then it was 100 million, 1 billion, and now supposedly it's 1 trillion, right? I mean, and it's read 1 trillion words. I mean, like, you can't conceive what reading 1 trillion words is. So in a way, it's very stupid.
They opened it up and just consumed, got all this input and scaled it.
It has essentially read everything that anyone has ever written.
It's basically we become the product in a sense. All the users became part of the product in a sense there. Yeah.
That's one way
or training it. Yeah.
Which I think is somewhat unkind. You hear that a lot, but I don't actually like that expression. It's not that we're the product, we're the teachers.
Oh, I like that.
Machine learning is the machine is learning to speak by observing people.
Yeah.
And so it's not surprising that its prose is remarkably human-like, because that's what it was trained on, right? It's like a child learning to copy its parents. And then the most recent thing in all of this is a GPT-4, where they haven't revealed what they did with it. But the one thing that they revealed, which we knew anyway, is that it is this thing called reinforcement learning from human feedback, which again you can think of as when a child is learning to talk, they get feedback from their parents as to whether they're being it right or wrong, and they get better that way. And GPT-4 is just doing this on a massive scale by interacting with its users. So that's, I think, the most recent piece of this series of improvements.
I'm assuming you're excited about all this and these developments.
Well, I mean, of course I'm excited. This is what I've been working towards my whole life. In fact, I was prepared. When I got into AI, it was during the AI winter in the early 90s, right? It was AI was at its nutty. There was a previous AI boomlet in the 80s, which people barely remember now. But then things kind of went downhill. And when I got into the field, I knew that that I was in it for the long haul. I was prepared for the level of AI that we have now not being reached in my lifetime. And it's the same experience with a lot of other AI pioneers, like Jeff Hinton will say that to you, like he didn't think that things would get this far this quickly. But here's the thing: progress is an S curve. And we human beings always think things are going to go on linearly, and then suddenly they pick up and you're surprised. You shouldn't be, but you don't know when it's going to be, right? And again, relevant to the future, I don't think we're about to hit the singularity. We are on an S curve. We are on a phase transition. The question is how much higher it goes and where it stops and for how long. Yeah. I remember talking with people like Ilya Sutskever even a few years ago, where he was saying well, progress in deep learning is slowing down. I'm like, I don't think so. I think we still have further to go. Well, the S curve was still accelerating, and it still is. But so yes, I am excited. Yeah. Just to be clear, I am not one of those AI alarmists that we hear a lot of in the media today. But it's not because I don't think there's nothing to worry about at all, right? I think AI is a singularly powerful technology that can be used for good or bad, and there are many things that can go wrong. And I am guardedly optimistic about the future based on our experience with technology today, which is we humans, we make the good things happen and prevent the bad things from happening. So we got to have that conversation. But I think the problem with a lot of discussion right now is that it focuses on the wrong dangers, on things that are far-fetched or really not well thought out. And then the solutions to that actually detract from the solutions to the real problems, which we can also talk about.
Yes, I do want to talk about. But since we're on ChatGPT and OpenAI and large language models. By the way, to your point, I want to point people to your Twitter account because I love your short blurbs. One of them, you said, AI alarmism is Genesis' fault. The story of the creation rebelling against the creator has a powerful hold on our imagination. Then there's a bunch of them that I've written here that I kind of like. But before we leave, the current state of ChatGPT and I guess Bard to some degree. But can you explain hallucinating in AI? So they're calling it hallucinating when they make incorrect claims about material that maybe it's not in their training set. Is that because hallucination kind of implies perception? Because every day stories are coming out and some people are talking about bias and some say it's bullshitting. In other words, to me, bullshitting imputes some kind of human motivation to something which it isn't. So can you weigh in on this? Because I also want to talk about illusion in humans.
Yeah, exactly. There's the hallucinations in the machine and the hallucinations in the humans. So hallucinations, I think, really are the Achilles heel of large language models. And it's a problem that's very big. It really limits their use. And it's not, I think, going to be easy to fix. Because when ChatGPT or whatever generates this text, you really have no idea whether it's going to be brilliant or completely bogus. It could be anything. And if you know how a large language model works, you can see why this is the case. It's just generating the next word. And here's something that I think everyone, policymakers included, should be aware of. It's called a language model because, for example, in speech, there were two parts. There was the acoustic model, which is the model that connects the real world, what you just heard, the waveforms, the sounds, to the text. Or in translation, in translation, there's the model that actually translates, say, Spanish to English. And then the language model is just to make the output look good and internally coherent. I could have a very accurate translation from Spanish to English that doesn't sound very good in English, right? It's kind of clunky, maybe not even very grammatical, not elegant. And so the purpose of the language model is to make the output look good. And the thing that's borderline comical about LLMs is that that's all this is. We've forgotten about the module that connects things to the real world. This thing is a bullshitter by nature in some sense. Now, if you read a lot of text, you're also learning a lot of things about the real world. So accidentally, in some ways, actually not in some ways, accidentally, these large language models will end up, learning a lot of things about the real world. But in essence, the whole idea of using a large language model as a knowledge base to answer questions is broken. And fixing it is not going to be easy, also because the deep networks are extremely opaque and no one really knows how they work. So there's a really serious problem here.
Would it be fair to say, based on what you just said, that let's say you're talking to AI and let's say it's ChatGPT and you talk about your car or something. Mm-hmm. So, and it may have some information about what a car is, whatever. But if I'm talking about my car, it has no context of the outside world as to car, what it is and how it relates to me.
So that's a good example. So it probably hasn't seen your car or know anything about it, but you can tell it things about your car. But what it knows about cars, and again, this is very, very different from humans, is it has no experience of driving a car or what a car is. It has read a lot of stuff about cars and somehow it's connecting it all together. But then there's basic things about how a car works that it probably has no idea about. That's the problem. Of course, there's people, and we're going to see a lot of this in the next few years. This has already been done at places like DeepMind and whatnot, where you also input video and even robotic interaction and whatnot into these large language models. And that's definitely an improvement. We'll see how far that goes. Because again, they are good for predicting not just language, they're good for predicting commands, for example. And they can also learn from video and then learn to correlate the video with the language. And again, people have been doing this for decades. I think with large language models, we can potentially do it much better than before. But as of now, when you talk to something like ChatGPT, it really just, it has seen a lot of characters on pages that have to do with cars. It can know very precise things that will surprise you with how smart it is, but it can also fail in ways that no child would. It's okay to colloquially describe it as bullshitting, but you're right. Part of the problem that we have in AI is that we don't actually have the vocabulary, at least the
That's
non-technical
interesting.
vocabulary,
Yeah.
to talk about what AI does. But we're going to very rapidly acquire it. I think this is already starting to happen. And bullshitting, you're right. If I'm bullshitting, that means that I know that it's false. The problem with ChatGPT is that it has no idea.
Yeah.
ChatGPT is just generating text, right? I mean, computers have generated what we call canned text from the beginning, right? Like it generates a message for you. Please, are you sure you want to delete this file, right? That is just a sequence of characters that was stored in the computer and is given to you when that happens. The computer doesn't like Windows doesn't know what delete and file mean. And in a way, ChatGPT, for all its sophistication, it's still the same thing. It doesn't know what any of that means. It doesn't really know the rules of dialogue and theory of mind that humans have. Now, it can fake it in various ways. And again, this has been a criticism, so people are working on it. But at the end of the day, these large language models, they don't know what telling the truth means or BSing or any of those things.
Which brings me to kind of the illusion in humans now when they interact with something like ChatGPT. It's easy to fall under this illusion because for the first time we're having, for many people, conversation. It can carry on a thread. So there's some back and forth. And you couple that with our highly evolved social signal detectors, right? So we have a tendency to probably anthropomorphize things like things that aren't human because they seem like us. And in researching this, you probably knew this. I wasn't aware, but in the 60s, this was a problem. Joseph Weizenbaum created a chatbot called Eliza. Same problem, even though he would tell people, look, this is not, doesn't understand you really, but it didn't stop people from projecting understanding to it. I would guess this is a risk to AI from a standpoint of legislation, if in fact people feel threatened that this is a kind of a sentient thing, or they fall under that illusion. What's your opinion?
You're exactly right. The biggest problem when humans deal with AI is that they anthropomorphize it. This is very natural because we reason by analogy. And when we see something intelligent, the only other intelligent thing is we know is us and maybe other animals. And so immediately we project onto the computer all these human qualities that just aren't there. The entire discourse about ChatGPT and so on is permeated with this, even coming from researchers, people who should actually know better. It's just irresistible trying to do that, right? And we're doing it in so many levels, in so many ways, that it's very hard to get out of this. Now, at the same time as the people acquire more experience with things like ChatGPT, they will start to form a mental model of what that thing really is. And that's, that would be great. Right now, in the meantime, you're correct. People are passing laws and considering laws to pass that are based on treating the machine like it's a human. We sometimes call this the homunculus fallacy. It's the fallacy that inside the AI, there's a little homunculus, a little man who's pulling the strings and has all the biases and emotions and consciousness and will, and that it just doesn't. I mean, like, only the other day, Jeff Hinton gave an interview, I think, to CNN, where he said, like, when the machine wants to something, like, the machine doesn't want to anything. Machines don't have wants, right? And this is Jeff Hinton, like the founder of deep learning, if you will.
I saw Yuval Harari, just some big article. I can't remember where I saw it. He was very alarmist. He was, and it may go back to this bullshitting, hallucinating aspect of these large language model kind of AI, consumer driven. He was saying stories are so important to us as a culture, right? And politics and what have you. And he's worried about the fake news and getting worse and getting worse, but getting more persuasive because they're AI driven. I mean, I was a little surprised because he's coming at it from a cultural standpoint. But then again, there are other people that I've heard make the argument of the fake news aspect and what have you. Are we going to be persuaded? I do understand the deep fake risk where, there's an image, there's a video that's, impeccable of you saying, whatever.
Right. So I was not surprised. So he signed the AI moratorium letter, which did not surprise me. It's interesting, the different people who signed it, the different quirks that made them sign it, they're often different. And the people on the outside often don't realize this. I think if you know Yuval's thinking, that piece is not surprising at all. It's completely consistent with the way he looks at things. However, it's surprising that a historian would be so naive about some things. Like, for example, in the 50s, remember the book The Hidden Persuaders? This was the heyday of TV advertising. It was like, they are going to persuade you, like, the TV commercials are going to manipulate us up the wazoo and, make toys.
And you remember the subliminal snippet of a 35 millimeter. Yeah, I remember that too. Yeah.
Exactly. So, but then what happened, right? What happened was that we learned to see through those ads, and we got jaded, and now they're actually very ineffective. And the same thing is already happening with these bots. Humans are not stupid.
Were you not around for the last presidential election, Pedro? Humans can be very... Sorry.
No, okay, very good. So another point of this, which is the other leg of this argument that also breaks, is that actually there's three. Like there's the notion that AI would generate, worse and more disinformation. Like, I actually don't think that's going to be the issue, but let's leave that aside. There is this conviction in certain sectors of society that online disinformation through the 2016 election to Trump, this is complete nonsense. People have studied this very carefully. Cambridge Analytica, we know Cambridge Analytica. Cambridge Analytica was a BS shop. They said we do all these things that they didn't. There is no evidence whatsoever of anything that Cambridge Analytica ever did having any influence whatsoever on the outcome of the election. And if you look at all this information from Russia and whatnot, like, the effect of that was marginal compared to, say, Fox News. This just doesn't even compare. So this whole preoccupation with this information is really born of honestly finding scapegoats for the fact that Trump beat Clinton.
Plus, there's still a division, and so that we're fractured in our conversations about these things, which can be a good thing, because it says no, ideas are still being fought in the arena.
It's extremely important that we have a very wide diversity of views on AI, as on anything else, as long as they are informed views. I don't believe in this notion of like a committee of experts and regulators is going to decide what is the way forward for AI. That doesn't work. What works is what OpenAI has been doing, and Sam Altman has been defending it, and I completely agree with him. Is like, no, you release it, you let everybody play with it. I mean, in open source software, we know that the most complex software has to be built by having the most eyes looking at it.
Turn on the light, and the boogeyman disappears. Right? Can I call you an optimist about all of this AI?
As I said, a guarded optimist. So it's
guarded
an
optimist
condition. It's like, if we decide to not worry, then there's things to worry. If we decide to worry, then I'm optimist.
Well, not a blind, not blindly, right?
But not blindly optimistic. Yeah,
but you're on the opposite side you're on the sober side of optimism. You're not an alarmist, at least yet. So, with that said, is that because of? And it seems like when I read your writings, you are against at least the legislation or the proposals that are out there now. These may change. I think you're against that, and I think it's because you are on the side of risking for the known unknowns. You want the progress of knowledge to continue.
That's part of it, but that's only one part. This most recent wave of AI moratorium and whatnot, I actually haven't seen any very concrete proposals about what people really want to do. Right, so it's easy to say, motherhood and apple pie, AI for the good. Like, who doesn't believe that, right? But the question, and guardrails, right? What very good guardrails, but what exactly should the guardrails be? I'm waiting to see what those proposals are to then, comment on them. But we already have, for example, the European Union, California, they have legislation about, the data economy, like the GDPR is this infamous thing in Europe that has been, that was a terrible idea, right? But some people don't seem to think it was a terrible idea. And now they have the Digital Markets Act and the Digital Services Act, and coming up, the AI Act, which was an absurd thing. Again, maybe we don't need to get into that, but now apparently they've taken a pause to revise it because ChatGPT has made a lot of it outdated, as anyone knew was going to happen. So there are a lot of bad ideas about for legislation, and those ideas can be harmful because they can prevent progress. And so you're right. So AI is a technology with an enormous upside, and we want to explore that upside. We also want, as I said, we want many different people playing it when acquiring experience with it. Restricting the use is actually, I don't think, the best, the best thing to do. Also because, the bad guys are going to be using AI anyway. There are many reasons why I think so here's another big one, which I think is sadly absent from most of this conversation. The typical solution, so there are short-term AI worries like disinformation and long-term ones like, the end of civilization that strangely all get conflated as if this was all the same thing or on the same time frame. But then the solution to all of these is one way or another to limit the intelligence of AI, which is precisely the wrong thing to do. What is unsafe is stupid AI. No one has ever been harmed by overly smart AI. People are harmed every day by overly stupid AI. Dumbness is like most of the mistakes that AI makes. It's not because it's biased or has evil intent or whatnot. It's just because it's stupid. It's like the hallucinations. It doesn't know what it's doing. So the way you make AI safer and more reliable is by making it more intelligent. So actually, what we need to make AI safer is not to put a moratorium on research, is more and better research.
Well, I think that's what the fear is, it being more intelligent. Is that the argument, that if this thing becomes super intelligence is our end or something?
So there is the fear. And let's look at two examples, a near-term one, disinformation, and long-term extinction, right? The near-term fear, from Yuval's essay is a great example that is like, they're going to get so good at manipulating us that they can do anything they want with us. This is the near-term fear. But again, this ignores the fact that AIs don't want anything. The AIs are just this is one of those things that everybody
they're imputing motivation, right? Again.
Yeah.
This is AIs. It goes back to go ahead. Sorry.
Right. But so AIs don't have all these human things, right? Motivations and whatnot. What do they have? And the analogy that I think that I think is a good one is a car, right? You don't actually care how the engine works. That's for the mechanics. But to drive a car, you need to know how to use the steering wheel and the pedals. And AIs have a steering wheel. That's what we should be talking about. The steering wheel is this thing called the objective function. The objective function is a simple mathematical formula that basically says what it is that the AI is trying to maximize. For example, in social media, famously, it's engagement. It could be click-through rate on ads, right? So now we get to decide what the AI does, and the learning does not override that. So this fear that somehow AI will get too smart is actually mistaken now. And on the other side, right, detecting disinformation at places like Meta, for example, or Google or anybody, is done primarily with AI. The smarter the AI, the more current misinformation and disinformation it can detect. If we get better AI, people will be able to generate better disinformation, but they're already generating very good disinformation. That's really not the problem.
We get better self-driving
AI
cars.
Will get better at detecting disinformation, which it really needs to. If you took the AI away from Facebook today, God help us, right? And so, but disinformation is actually hard to parse and understand what is being, how they're disinforming you and whatnot. So more AI will let us, detect this information better. So this is, I think, a good example of what I was just talking about. On balance, we want more intelligence, not less. Now, in the long term, this is the thing that has some of like the AI pioneers like Jeff Hinton and Noshio Benjo worried. And it's a very old, worry, except now it's suddenly topical. But I think it's still, it shouldn't be as topical as it is. Let's put it there, which is, imagine an AI that is much smarter than we are. And then it wants to take over. Oh my God, right? It's going to outsmart us. This is a natural thought to have. And of course, Hollywood likes to foster it because it makes for good movies, like Terminator. But there's a couple of problems with this. Number one is that AI doesn't want anything. The only thing the AI wants to do is maximize its objective function, which we determine. So the idea that a smart AI is necessarily a danger to us or out of control is actually is mistaken. So, for example, consider trying to cure cancer, right? We want an AI to cure cancer. In fact, it's going to take AI to cure cancer. If you talk, to the more informed cancer researchers, do you really want to limit the intelligence of that AI on the basis that it might decide to start killing people instead? This is ridiculous, right? This is a joke. And to make a more general point, The technical definition of AI is that it's solving what are called NP-complete problems using heuristics. What does this mean? An NP-complete problem, basically all the interesting things that intelligence is used for, are problems that it takes an exponential amount of time to solve, but checking the solution is easy. They are problems whose solutions are obvious in retrospect, but not before. This is exactly what AI is, technically. And the point of this is that our job is to check the solutions. We set the objective, we set the limits, the constraints, and we continuously check that it's doing what it's supposed to be doing for us and not having negative side effects and whatnot. And the good news is that our job is exponentially easier than the job of the AI. So we can have an infinitely powerful AI and not have to worry about like, oh, the AI is going to, under the hood, somehow decide to attack us, right? That just doesn't make sense.
You mentioned it early, the former CEO of DeepMind, because I was going to say to you, who is Congress talking to? But then I'm thinking, well, wait a minute. There's some dissenting voices within. You guys all don't agree, everybody in the AI community.
I'm glad you brought up that point. It's not there are some dissenting voices. So, for example, I have come out against this idea of an AI moratorium. So has Jan LeCun. So has Andrew Ng, another very famous AI researcher. So there are definitely people on both sides.
Andrew came out against. Okay.
Yeah. No, but here's the very important point. It's not like those of us who don't want an AI moratorium or aren't alarmists are dissenting ones. It's the opposite. The majority of the AI research community thinks this idea of AI ending human civilization is ridiculous. So we're the majority. But as usually happens, it's so predictable.
It's not newsworthy, though.
There's a few people, right, who got very worried. I respect their opinion, but now the media is going to town with it, like interviewing them left and right, rousing the rabble, if you will, with these words. And then the politicians, the Bidens and the Schumers get in on the ad and say like, oh yeah, maybe we need to regulate AI. And then before you know it, some very bad things have been done, as they were in Europe. So the majority of the AI community is on the side of like, this alarmism is ridiculous. We got to don't let the media biased sampling of the AI experts make you think otherwise.
To your point, by the way, I've developed a couple of tools using these AIs, and they're consumer facing, and it's great with all kind of caveats wrapped around them. But when you have customers, as you know, Pedro, when you have customers, it's the happy ones who are silent.
Exactly.
So it's like the only attention is the attention that's negative, and you shouldn't have attention there. But
I completely agree with your point. And here's the thing. The people that don't have those worries are in the AI community are busy doing AI research. We have other things to do, right? But then there are the people, again, I agree there's a place for them, and I'm not trying to, put them down or anything. That have formed these institutes like the Future of Life Institute and the whatever it is, the one at Oxford that Nick Bostrom is in, whose job is to worry about existential threats to humanity and whatnot. And they've latched onto AI as the biggest of these threats. And this is what they do full time. So there is a lack of balance in the people, being alarmist and the people who aren't alarmed in terms of like how much they speak up and how much their voice is heard.
So it would be a very boring science fiction movie if AI just did everything for us and everything was fine. Nobody's going to watch that movie. Okay.
No, but I'm glad you said that. So this novel that I just finished, that is about AI among other things, was precisely motivated by this. So I met Ron Howard at one point, the film director, right? Very good film director. And I complained to him that why does Hollywood always depict AI as the big evil thing, right? It's a mantra. It's always the same over and over again. There's very few exceptions to this. And he shrugged and said, well, that's the way we tell an interesting story. If you want AI to be depicted in a different light, come up with a good story to tell about it. And so what happens? So this novel that I chose is called 2040 because it's the story of the 2040 presidential election. And it's an AI that is not evil, but is also not a perfect AI that does everything for you. It's an AI that it's like ChatGPT. Sometimes it gets it right, sometimes it gets it wrong. Behind the scenes are the people who program it panicking about when it's going to make a mistake. And then, of course, it screws up badly in some ways, not giving any plot points away.
But you got to get this out.
AI.
You got to get this out.
I want people to see AI as that versus Terminator.
I just thought of an AI movie that I thought was in that vein, and that's Her. Have you seen Her?
Yeah. So exactly.
To me, that it's innocuous. And I do believe it's realistic, I do see people falling in love with some, again, back to this tendency to project human qualities,
Yeah,
anthropomorphize. I see that happening, people coming attached to things, but it wasn't a monster. It was just, it was very
exactly.
helpful, in fact, right?
So
I
I
thought it
agree.
was, yeah.
Yeah. So her is actually the best example I know of a movie that actually has a, meaningful description or depiction of AI, including the fact that then the human falls in love with her or it, right? Again, this
Hmm.
this happens, right?
Hmm.
And also including the fact that towards the end, then the human starts to realize, like, wow, this is not a woman, right? She's talking to 10 million men at the same time, and right, that's exactly the sort of like the moment of revelation that everybody should have.
First, I want to talk about goals. Is
Okay.
there an overarching goal here in the scientific community or in the computer science? Is there a goal, and is AGI it?
So for the majority of the community, in which I would include myself, the intelligence is not a goal in its own right. Intelligence is a tool that we can use to do a lot of different things, like self-driving cars and curing cancer and what have you. And in fact, the whole agenda, at least from my point of view, is to get it in everybody's hands so that each one of the 8 billion of us will figure out what is that they want to do with it and talk to it about doing it, right? And who knows what they'll come up with. Some things might be bad and we need to tamp down on those, but the amount of progress that this will create will be, I think, absolutely amazing. Now, there's a smaller segment, and I think the term AGI comes from them, artificial general intelligence, that have a more messianic view of AI, which, I think we should also take that seriously, is the notion that, and again, there's a variety of views on this, but to just paint a cartoon picture is AI is the next stage of evolution. This is not just about self-driving cars or curing cancer or whatever. It's like, human beings are a stage of life on earth and AI is the next one. And so we're here to make that happen. And that's the great epic. There's also the people who say, well, and then they're going to drive us extinct. And we need, people like, Eliezer Yudkowsky and whatnot. They're like, that's why we need to stop it because it's going to drive us extinct, right? But then it's like, well, maybe it's a good thing if our so Hans Moravec, a famous roboticist, had this notion of our mind children, right? Like AI are our children in some ways. So like that's what we're aiming for. It's not just solving problems or accomplishing utilitarian goals. It's really the great epic of life on Earth. AI is the next stage. Let me put it this way: on a daily basis, I don't think about any of that. Right. For example, Ray Kurzweil is probably the most famous of these transhumanists at this times call. Right. So like in 2047, the singularity will happen and humans will become irrelevant and so on.
I think you both are very similar in how you look at the rate of progress. Let's say 1950 to 1980, from 1980 to 2000. You think it's accelerating much, much faster.
No, well, it is accelerating, but we are extremely different in the following: is that Ray Kurzweil thinks that progress is an exponential, and I think that progress is a series of S curves. And
Okay.
honestly, he's
I didn't know that
wrong.
distinction. Okay.
Singularities don't exist, right? Exponential growth can't. A singularity is a function that goes to infinity at some point, and in the real world, infinities are physically impossible. So the singularity, as he originally construed, it just can't happen. And in practice, people have studied this a lot. Progress in technology and in other things comes in waves. So we are at a moment of acceleration in the S curve, but then it's going to flatten out. Right?
Which he didn't have the drop
Yeah.
in that curve.
Yeah,
Okay.
but people do this all the time because it's so exciting, right?
That's a good
Exponential stuff. It's
distinction.
like,
That's a good
like
distinction.
his entire book is overfitting exponentials to data, to past data sets. But again, if you look at all these other things, that like then there was the time came when things flattened out. One example, this is actually Moore's law. Moore's law is already starting to flatten out because things couldn't keep getting faster forever. So the same thing will happen with AI. So I think there will be a phase transition. I don't think, and sort of like very relevant to these debates, Ray's view, and unfortunately the view of a lot of people, and it's a natural one, is that at some point AI will just be completely beyond our understanding, and that's why we have to be afraid. I actually think that is not the case, is that no matter how far AI evolves, we are actually not ants. It's not like humans and ants. We can make it stable by design, right?
Okay.
And the analogy that I often give is between us and our genes, right? Our genes are not smart, but they control us.
Let's say AGI, artificial general intelligence, or And let me make sure I'm right about that. That's the equivalent of human level intelligence, or is that supra?
Well, it can be both. So,
Okay. Okay. Right.
an argument that people like Nick Bostrom have made often, and I agree with it, is that in a way, aiming for human level intelligence is a little parochial, because any AI that is human level intelligent one day, the following day will be more intelligent than humans. There's no stopping point at human intelligence. So we go straight to super intelligence, and that's what people like Nick want to think about. The thing for me though is that, and that's why I don't worry a lot about that on a day-to-day basis, is like we're so far from even human level intelligence. There are basic things that we don't understand. So there's a lot of progress that we have to make on our way to human intelligence and then beyond. And now the thing about ChatGPT and the like is that in a way, they are real progress, right? Some people say like, oh, this is really all just happened one on. It's not. It's real progress. It will have a lot of impact. But it also, again, and this has been a constant in AI from day one, since the days of Eliza, that it also looks like it's much, much more than it is.
There are aspects that are superhuman even in chat. I mean, it can do things that I cannot do at the speed limits that I have. That's superhuman.
No, absolutely, right?
Okay,
But
okay.
notice, arithmetic, computers have been superhuman at arithmetic since the 50s.
It does.
And it used to be that, computer was a job description and was considered a sign of intelligence to be able to do addition and multiplication. So intelligence, this is another thing that unfortunately really impoverishes the discussion, that intelligence is not one thing. And when will the machine surpass us? In some areas, they surpassed us a long time ago. Civilization is still here. In other areas, maybe they never will, or it'll take a long time. And we got to think of this, in all these dimensions. People should get their minds around this.
Why is it so good at code, but not math?
Great question. And one of the best ironies of ChatGPT is that it does trillions of calculations per second, but if you ask it to add two numbers, it gets it wrong. It doesn't know how to do addition. It doesn't even know how to do what an IBM computer of 1950 could do, or your pocket calculator. In that regard, your pocket calculator is smarter than ChatGPT, right? So it is actually good at some kinds of math, very good. So you can give it some very hard math questions that would flummox a human. To understand this, you have to get back to this question of like, what is it really doing, right? It's figuring out how to predict what comes next from what came before. And for example, code by nature is extremely rigid. It follows very hard rules, like the syntax of Python or Java. And there are certain programming constructs that we all use repeatedly and whatnot. And those are actually much easier to pick up from a corpus than the complexities of literature. So it's not surprising that it's better at coding than it is at literature.
There was a mention of consciousness in some works by David Chalmers. If consciousness, so we're back to this sentience, right, in AI, and if consciousness is on a continuum, and on the one side we're talking about a rock, I'm going to set aside panpsychism, right? I'm going to set that aside. But let's say 0 with a rock, and then you've got humans on the other side. Is there any consciousness, in your opinion, in these large language models or in these AIs as they are now?
I think there's a negligible amount. Again, consciousness, like other things, is an S-curve, and at some point you suddenly get a lot more of it. And we human beings and other animals presumably are a good example of that. I think because of the way it works, ChatGPT has very little consciousness, although again, it can appear like it has a lot more than it does. So when that unfortunate Google engineer came out saying like, "Oh, Lambda is sentient," we all laughed about it, right? I mean, honestly, it was hilarious. While the media was running away with it as it likes to, but right, David Chalmers makes a very good point, which I also keep repeating to people, which is you can't say something does not have consciousness until you've defined it. So if you don't believe that these things have consciousness, the burden is also on you to say why not, right? So the whole problem of consciousness is that it's very hard to define, right? You could say, oh, well, I know it when I see it, right? The Supreme Court criteria. And by that standard, definitely ChatGPT has no consciousness. Now, what would it take? So, and again, David Chalmers, for example, has a very nice, he's the world expert on this. can we have a somewhat operational definition of consciousness, right? Consciousness is hard to define because it's subjective and we need an objective measure.
It's the hard problem.
Yeah. So you can look for the neural correlates of consciousness. There are people who do that. You can look for quantitative measures of consciousness. There's people who do that. I think if we apply any of these to, and David Chalmers agrees, to things like ChatGPT, it doesn't have a lot of consciousness, but it has more than zero. One of the AI pioneers, John McCarthy, he had this idea that people kind of ridiculed in some ways, but I think is kind of insightful. He said, I'm going to paraphrase him to our discussion, but like the simplest amount of intelligence, or the smallest, is a thermostat. And I would also say the smallest amount of consciousness is a thermostat, because a thermostat is aware of something, the temperature, and is capable of taking actions to achieve a goal with respect to that, which is in particular to keep the temperature at a certain level. So, I might speculate that in a way, consciousness is a thermostat writ very, very large. So that basic mechanism that exists in the thermostat, then you see as control mechanisms, feedback-based. I think having feedback is very important for consciousness. You have percepts, you integrate those percepts. There's a stream of data. This is what your brain is doing. It's continually integrating all these percepts and then figuring out how to act to achieve its desired state. This is really both intelligence and consciousness in a nutshell. And now you can ask, how much of that does ChatGPT have? And ChatGPT learned from a lot of information offline, but online it's incredibly dumb. It's not that different at some level from just spitting out canned text. Of course, it's very smart in some ways, but for example, it's not learning online from interacting with you. Unlike you and I in this conversation, it can use again, there's these hacks that are almost, ridiculous, but like what it does is it uses the entire previous conversation as its prompt. Right? This is clearly a provisional solution, but a real sentient ChatGPT would be having a real interaction with you, and we just don't have that yet. But things are going to progress in that direction, I think, at a fairly good clip.
Yeah, whenever I talk to people about using AI in some form, I said it's an augment. Use it to kind of give you ideas, but you make sure you check this and make sure you use the information. It's another tool. It's not a replacement. Which brings me to employment, because a lot of people are going to listen to this podcast. I just had one with Kevin Kelly, and we discussed AI. He's very much an optimist, but you're in the technical weeds. There's a lot of fear. In fact, the CEO of IBM just came out and said 25%, something like that, of work he sees is going to be replaced, what have you. My view generally has been that automation is likely to lead to more job creation than job replacement. Okay. But just because of my short history with previous waves of automation, I've seen it develop jobs. Do you think this is going to go along the same path as the same thing? Or do you think everybody's going to be unemployed to some degree that's a knowledge worker?
I agree with you. AI is going to create more jobs than it destroys. And we can, try to understand why that is the case. It's also not, I get this question a lot, as you can imagine.
I can imagine.
It's also not a reason for people in their different professions to ignore AI. I think the single biggest effect of AI on work is that it's going to change how most jobs are done. In any given occupation, there are many different tasks that you have to do, and typically AI is good for some of them, but not all, which means that the AI is not going to replace the human professional, but the human professional that uses AI is going to be able to do more of the interesting things, if you will, and get farther than the one that doesn't. So it's not man versus machine. It's man with machine versus man without. As you were just saying, AI augments your intelligence. It's like having a horse. We don't say, oh, once a horse cannot run us, we're doomed. No, we ride the horse and get farther. So I think this is the key thing about AI. Why? Well, first of all, AI is really just another form of automation, and we have 200 years of history to learn from. Every decade, people are worried about the jobs apocalypse that's coming, and it never happens. And by the way, right, when you see these predictions of 25% or 100% of jobs are going to be destroyed, when the McCormick Reaper came along, right, was automating farming, the McCormick Reaper could do the job of 50 men. And so 98% of Americans, 200 years ago worked in agriculture. Now it's 2%. Not 25%, 96% of those jobs disappeared. Are we all unemployed now? Well, of course not. We're doing all sorts of jobs that you couldn't even imagine then. And I mean, it's funny because I remember At the Milken conference a few years ago, Eric Schmidt interviewed me on stage, and we were having a conversation about this. And one of the examples that I brought up was precisely the one that you mentioned, which is like, in the future, everyone is going to be programming because they can do it in natural language. And imagine what happens when everyone can be a programmer. That's already happening. And look, the AI revolution has been ongoing for the last 10, 20 years, depending on how you count. Where's the unemployment rate in America? It's the lowest in memory. So why all the paranoia? Right?
Yeah.
Like, think of, for example, like, ATMs. Did ATMs put bank tellers out of work? No, they just do other things now. Now, there are some occupations that will be impacted, right? So I'm not trying to minimize that. The path will not be smooth, right? There will be a lot of disruption. There will be conflict. We need to try to make sure that as much as possible, no one is left out in the cold. People can retrain. People can change how they do their jobs, et cetera, et cetera. But in the end, for a variety of reasons, AI will create more jobs. And some of those reasons are the following. AI makes intelligence cheaper. What does economics 101 say happens when something gets cheaper? The demand goes up. So what's going to happen is this economic, in economics, this is called the lump of labor fallacy, that there's only so much to do, and once it's done, we're done. No, the cost of intelligence goes down, so the demand goes way up. The main thing that we're going to see with AI is AI being used for thousands, millions of things that we don't even imagine right now. And I understand that it's easy to picture the current jobs going away. What's hard to picture is the ones that are going to be created. But if we look at history, they are going to be created, number one. Number two, when the cost of something goes down, the value of its complements goes up. This is another basic point of economics, right? If I make butter cheaper, the demand for bread goes up, because now more people will eat bread and butter that couldn't afford it before.
It consolidates production, but it democratizes consumption to a degree.
In a way, or in the case of AI, this now varies with technologies. The thing about AI, again, counter to a lot of the fears, is that it's an incredibly democratizing technology, because it means everybody, like, what's going to happen with AI is that every one of us is going to have 1 million agents working for them, as opposed to, like, right now, if you're rich, maybe if you're Bill Gates, maybe you have 100 people working for you. Tomorrow, we are all going to have 100,000 people, or who knows how many working for us, except they're going to be artificial people. Yeah. And then, so to bring, but it doesn't end there. So at the end of the day, let's say, AI makes a lot of things cheaper, then people have more money in their pocket, and they spend it on other things. Like, for example, on more material goods, on eating out more, on better houses, which create jobs for precisely the kind of manual workers that we're worried AI will displace. I can see like people not seeing this, but when I see economists and like people who should know better worrying about the jobs apocalypse without thinking about this, that actually puzzles me. So to be fair, there is an argument that is important to address, which is what you hear in response to some already said, which is this time it's different. Oh, the Industrial Revolution automated physical work, and so we humans concentrated on intellectual.
They are saying it's different.
But now AI is going to automate intellectual work, and kaput, right? We're gone, right?
Yeah, where do we go from here?
Yeah, but now, again, there's the lump of labor fallacy, but the other thing is that, like, intellectual work is not all one thing, right? It's like we already touched on this, right? It's not like intelligence is one thing, and then AI is suddenly going to beat us at it. Like, there's going to be an evolving frontier between what humans do better and what AIs do better. And for the great majority of things, the best result would be via collaboration of humans and machines. And that's what we need to focus on. It's not like, oh, it's different this time because AGI is almost here. Well, first of all, AGI is not almost here. Sorry. Maybe it's 10 or 20 years or 50 years away. Who knows? But it's not almost here. And it's not like one day there's going to be AGI, right? So that notion that this time is different is based on, number one, a naive view of how fast AI progress, will be, even in the phase that we're in, number one. And number two, on a unidimensional view of intelligence, that things like, oh, there's manual work and, muscular work, and there's intelligence, and intelligence is one thing that is going to get automated overnight. So that sort of like rebuttal of this argument is also, doesn't really hold water. So a great example of this, which goes back to machine translation, is the previous statistical machine learning translation system that Google had before deep learning came along was already pretty good. And there were these fears that they would put translators out of work. If you talk to translators, what has actually happened is that they use Google Translate as a first pass.
Oh, that's a
and then
example.
They refine it. And so what is the consequence of this is not mass unemployment among translators, is that they can translate, I don't know, 10 times more things than they could before. Things that you wished you could afford the translation for, like a book that you wanted to translate, but it's only going to have 1,000 readers, so you couldn't afford the translator. Now you can. So there's actually a nice example of exactly what I was talking about.
In the 80s, I was in India and I'm driving Pedro on a bus through a province. And so each of the provinces had their own. This one was communist. It was just, I didn't understand the politics, but this particular province I drove through, I saw an old lady squat down and she was chiseling a big rock. She was chiseling. And I asked somebody what she was doing. And they said, that's her job. She's making gravel. And I said, why don't they use machines to just grind it up? And they said, they don't want the unemployment. Now that's an extreme example, but so many things. I'm like, well, wait a minute. As soon as the machine does that work, she can do something else that's less, again, very extreme, but I think it may apply. Jobs change versus, they do go away, but other things replace them, right?
Honestly, unfortunately, I don't think that's an extreme example. I know many other examples like that. And in fact, I'm from Europe, and in Europe, this is something that people say all the time. Even in America these days, it's like, oh, you got to just keep these jobs. I understand like the impulse, but it's incredibly short-sighted. Imagine if you had kept the jobs of the farmers 200 years ago. We'd all still have jobs as farmers, and most of what we know wouldn't be here, and our lives would be much worse.
So is AGI way out there 50 years, or can we cut that in half?
My short answer is that we don't know. Anybody who gives you a date is either imagining things or BSing. There are these polls of experts where the average comes out at 50 years. What I say is the following. Progress is very hard to predict precisely because it's not an exponential or linear. It's these series of S-curves, and you don't know where the next plateau is going to be and how long it's going to last. Mm-hmm. At one end, maybe there's a kid that has already invented a master algorithm and we don't know it yet. It's possible. Some people say backpropagation is already the master algorithm. But even if that's the case, this will take decades to play out, right? So at a minimum, this whole transition to AGI it can't physically happen tomorrow because humans would be the bottleneck. At the other end, there are a lot of people who say quite seriously that that'll never happen. We will never get to human level AI. And there are different arguments for this, but the one that I find most, we have to take seriously is that there's the argument that there's something ineffable about the human spirit, as
and consciousness.
I'm on the materialist side of things, so
okay.
I can't prove that that's wrong, but that's not something that keeps me up at night. But another one that's very, very central to AI research is that it's just too complex. It's the argument that there's this saying, I forget who said that, like, if we were so simple that we could understand ourselves, we'd be so stupid that we couldn't, right? It's a whole community of scientists trying to understand intelligence. So I don't think that's going to be a showstopper. So I do think we will get to and way past human level intelligence. But, it could take decades.
But you do think we will get there? You do think we'll get there? Okay. That's
what I usually say is it's going to be, for a short answer is I think it'll take 100 years, give or take an order of magnitude.
Okay.
So it could be as little as 10 or it could be as much as 1,000. I don't think it'll be less than 10. I don't think it'll be more than 1,000.
So AutoGPT, it's prompting itself. Is that going to really accelerate this, or?
That is not yes, that's a question that comes up, and it's a natural one. It's not a tailhook for a couple of reasons. One is that compare that with what DeepMind did very successfully with AlphaGo. And in fact, it's one of the oldest ideas in AI. It goes back to the 50s. It's the idea of self-play. You play Go, you, the computer, play Go against yourself millions of times and keep evolving that way. Right? This is a very smart thing to do, and it works really well. But number one, at some point, you stop getting better. Very important. And number two, games are a very special situation where the whole world is inside the computer. Precisely the defining feature of LLMs is that they can't bootstrap themselves in this way because they can't learn from themselves something that they don't already know, right? They have to interact with something. Two bots interacting with each other may do, I don't know, something interesting or not, but they will not understand the world because they have no more access to the world than one of them does.
A system just got beat that's on par with AlphaGo with the game Go. And a human kind of hacked the shape of the stones or something that was outside of, kind of its model, and it beat it like,
Oh yeah, and there's countless examples of this. The systems are, again, this is something people have to bear in mind about AI. The systems are extremely brittle. It's easy to blow your mind with a demo, and in fact, this is what OpenAI has been doing on the largest scale. And the demos, like it's hard to not be dazzled.
It's so novel. It's so
Yeah,
novel. Yeah.
yeah. But then you tweak the question a little bit, and it falls completely flat in a way that no human ever would, right? And I don't see that being fixed just by having the thing work with itself. Now, is it like, in a way, the dream of machine learning and the master algorithm is precisely that, and this goes back to the 50s and Alan Turing and I.J. Good and whatnot, is that if you have a machine that can truly produce a better version of itself, then it could go very far. But again, and this is really the whole idea of the singularity comes from that, right? And again, I.J. Good had that idea long before Ray Kurzweil did. But here's the thing: is that, again, that cycle of improvement is not necessarily exponential. In fact, typically what happens with cycles of improvement is that finally the progress gets smaller and smaller. It's like the growth rate of an economy, right? You can't grow at 20% forever. Then it becomes 10, and then 5, and then 1, and eventually it plateaus or is progressing slowly. So there's no reason to believe that an intelligent AI that could produce a better version of itself would be any different. So again, we're going to have a phase shift, and it's going to be a very big one, but not a singularity.
In the next couple of years, do you buckle up? Is it going to be pretty cool?
It is going to be pretty cool, I think. And I think we should buckle up. Again, how far and how fast this is going to go is very hard to predict. Some things are harder to predict than others, and AI in particular is very hard to predict because, like, anybody could tomorrow have the next idea that brings another wave of progress, or then we could get stuck for 10 years. So I think I like to think of this in the following terms. There's what you can do with the AI that already exists. If there was no more progress in AI, things like ChatGPT as it is, as people learn to use it and whatnot, this is going to have very broad impact. And lots of other AI, besides LLMs, right? So even with just the technology that's already out there, there's going to be a lot happening, a lot of startups, a lot of companies, a lot of new business models, a lot of innovations. So as it is, right? But then you can ask, if you continue, as all these companies like OpenAI and Google and what are doing, if you continue to tweak LLMs and try to fix these problems that we've described, how much farther will we get? My feeling is that we will get substantially farther, so we're not at the top of the S curve yet, but it will plateau well short of human level intelligence. So a lot of these things that people are saying are not going to happen. There's going to be disappointments. A lot of people are going to, a lot of companies, this has been happening with every decade. They're going to try using AI thinking it's going to be some great magic, and then they're going to wind up disappointed. Now, what is it going to take to get to human level intelligence? Well, that's what my research is on. I think we need things we need something fundamentally better than large language models. It's not something that you're going to commercialize tomorrow, but for the 100-year horizon, that's really what at least we, the academic researchers, should be working on.
How does my audience and me and everybody listening here how do they keep up with this in a balanced way? The news is just crazy, and people that are not experts are writing about it, and experts are writing about it, and it becomes overwhelming to a degree. I'm going to encourage my audience to follow you on Twitter and read what you reread your book. By the way, it's very interesting. But what other resources should we plug into, or people that we should pay attention to, or read, or what have you?
So you're right. So just looking at what the media says is not the best guide. It is actually, I wish I had a bunch of great resources to point to. It's actually, this is why I wrote the master algorithm. I got frustrated with the lack of those resources. And okay, I'll write.
It's just moving too fast to kind of.
And even like the AI and like deep learning is particularly perverse in that it's incredibly opaque. The people who invented transformers have no idea how they work. They just happen to work. They hacked them until they worked. So even we, the AI researchers, don't understand things very well, at least at a certain level. There are a lot of people, an increasing amount, trying to understand what goes on. I think, following the right 100 people on Twitter is actually a pretty good idea. People like to disparage Twitter and whatnot, but if you follow, a good choice of 100 people in some,
if you curate lists
with different opinions, you kind of like they'll give you pointers, like, and they'll give you snippets and whatnot, and that's actually not bad. Every now and then I see an essay, for example, on AI that actually I think is quite on the mark. I don't have a general rule for who or what or where to find them, but they are out there, and hopefully they percolate.
Did you follow anybody? I'm gonna see who you follow.
No, yeah, I mean, of course, I follow a bunch of people. Again, I try to follow a balanced set of people.
You want to hear what the other side says? Yeah,
exactly. Not just the other side, not even the other side, but there aren't two sides to any of these things. There's 100 sides. And my biggest worry is that we missed the 101st. That was the really important one. So, yeah.
All right, last question. Going to give you a billboard in Times Square or somewhere where, millions of people are going to see it. And you got to say something about AI. You want to say something now to people about AI. You want to get a message across. What do you think it'll be?
Learn to use AI. That's my message. You want to learn to use AI as a professional, as a citizen, in your personal life. The more you know how to use it, the better use you'll make of it, the better your life will be. AI gives power like any technology. It gives power to those who understand it and use it. So if you don't learn AI, you're not going to be part of the discussion. So learn to use it. Again, you don't have to learn how the engine works, but learn to, drive the steering wheel and use the pedals.
Pedro, thank you so much. Very helpful. I really enjoyed it.
Yeah, this was great.
Well, that's a wrap. Thank you for listening. If you enjoyed it, do share it with your friends and on your social platforms. Big thanks to Sam Williams, my audio guy, and the beautiful bumper music you're hearing is Michael Petrovich's Bella Luna. For all my show notes or resource links, visit larryweeks.com, and we will talk again soon.